We thank you very much for joining us today and take the time to discover opportunities of one of our system solutions can offer you. During the webinar, of course, questions are possible. Please use the chat room on the right side. And we try to answer your questions live and individually. So your questions in the chat box can only be seen by the presenters and not by other participants. So we will either answer them directly in the chat, or we might keep them until the end of the presentation and answer them verbally. If there is any detailed follow-up required from your end, we will give you the contact details at the end of the webinar, or simply submit your email address in the chat questions, or we take them simply from your registration. So let's go through the agenda. So we will cover a little bit of what is Hemisphere today, or for all of you who don't know that. Then we go through the grademetrix excavator solution, components, some case studies. Then my colleague Ronald will do a software demo. And after that, we touch a little bit the grademetrix stakeout features. And then at the end, we will do show you a couple of options for grademetrix on which kind of machines or applications you can use it in addition. So let me just quickly present our team. On the right hand, you see Ronald Ade Ferreira. Ronald is our EMEA sales field application engineer located in Madrid, Spain. He will run you through the software, as I said earlier on. Ronald joined us in 2021 and has a 15+ years experience in developing, installing, and supporting machine control systems and positioning solutions in both construction and agriculture applications. And in his career so far, he served for major brands like Trimble and Leica Hexagon before he joined Hemisphere. On the left, that's myself, Jürgen Reinecke. I'm the responsible business development person for the EMEA region. And mainly responsible for our key accounts and channel partners for agriculture and construction. I'm in this business now for 30+ years and served in different positions in the machine control and positioning business, located to AgTech, Topcon and Trimble, followed by a 10-year job at a company called Prolec in the UK. And then I joined Hemisphere in September 2017. So what's Hemisphere today? You can see we have about 110 employees located in different various locations in the US and Canada. Part of our company is also Outback Guidance, which is more involved in the agriculture steering business. We are holding, now it's almost over 40 patents, and we are 100% subsidiary of Unistrong of Beijing, located in China, where all the major production facilities are located. This touches a little bit the businesses that we are in. So started with OEM, ODM, boards, finished products in different applications, precision agriculture, which is currently probably our biggest market, where we also serve either the boards or finished goods to bigger OEM customers. Then we have machine control, which we are talking about today in different applications. And last but not least is we have the marine segment, where we supply either boards or heading devices to the professional, commercial, and recreational marine business. Just touching a little bit about the power of Hemisphere and Unistrong. So all of our products are developed in the US and based on our very rigid quality standards. But at the same time, we have the production facilities located in China. We just recently opened up a new contract manufacturing facility in Zhengzhou as a cooperation with a company called Foxconn. And all the development, design, production, until to the finished good is all in one hand, which is very seldom. We are just only one of three companies. And we, as you can see here, we are covering The ASIC design, we are covering the GNSS algorithms, the antenna design, the software design, from start to the finished good. It's all in one hand, and we control the entire process. So let's talk about grademetrix excavator site controlling guidance. Grademetrix excavator is packed with an industry-leading technology. It's very easy to use, as you will see later on, and is delivered at a very affordable price. The system can be installed and calibrated in less than 1 day, including all your buckets. So from mini excavators all the way up through to large civil or mining machinery, all are covered either by the mastless VR500 all-in-one antenna or VR1000 dual antenna solution. Grademetrix system fits straight into existing site infrastructure where you have already systems in place with all the same formats and base station corrections. It also offers best-in-class 3-year warranty on all expensive components for peace in mind. Increase efficiency, and your ROI could be as short as a matter of months. What we also have in mind is the 2.5D market. So we want to enable the customers to use GNSS at every site. So this embedded function in grademetrix allows you to use the GNSS guidance technology for a vast array of simple, useful applications. Here, without the need for complex 3D files from survey. Using just only a couple of keystrokes, you can easily create simple layers, single or dual slopes, ramps, and even roads. And Ronald will show that in part of his presentation later on. While doing that, you use your GNSS as a reference. So let your own base station available as an option to the kit self-survey and provide RTK corrections. You will need no survey points, no local transformations or projections. On top of the 3D model benefits, the 2.5D functionality will significantly speed up your work cycles and dramatically reduce your ROI time. Simply put, it helps both new and veteran operators to do the things right first time and in less time. What is embedded? So use probably the most modern RTK engine available in the market. Our latest multi-frequency multi-GNSS solution uses every available satellite in the sky as a standard feature and not as an option. It offers full satellite constellation for maximum accuracy and maximum coverage in difficult environments. Beidou, Galileo, and QZSS are all within our standard solution. Nothing to pay for, not just GPS and GLONASS. Therefore, it will reduce the downtime of your GNSS machine control fix significantly, as a result, also expensive machine downtime. Especially in difficult environments like open pit mines, where we have later on show a case study, or in urban canyons, you will see a major difference if you have more satellites available. Also, using our own proprietary Atlas L-band signal, you will get the ARTK feature as a standard setup in your hardware configuration. So if you lose your RTK fix using a base station or N-trip data, our Atlas L-band signal will help you to keep the RTK accuracy for at least 10 to 15 minutes. So in order to help you planning your jobs, Hemisphere also offers a GNSS mission planning tool. Using the tool, you can enter your job site location, the time of day you want to work, and possible obstacles in your way. And as a result, you will see a detailed plan of satellites available. So that is something you can see and find on our website. So talking about the solutions that we offer on the machines. So this excavator solution is powered by hardware components that have undergone extensive shock, vibration, and environmental testing to stand up to the harshest job site conditions. The solution that we offer for compact excavators comes with an Iron 1 PC, which you see on the left bottom, a VR500 vector antenna, and a gyro-stabilized angle sensors. So the Iron 1 is the place where heartbeat of the system lives and all information come together. It's embedded in a very ruggedized IP67 rated housing, featuring an 8-inch daylight visible touch user interface. It's made to withstand harshest environment conditions on a normal job site. The Iron 1 runs a Windows 10 operating system, and it offers full connectivity using Wi-Fi, Ethernet, and a GSM modem for worldwide usage. The combination of Windows 10 and an activated SIM data card inside the Iron 1 also would allow your local distributor or Hemisphere support team to dial in your system and offer online remote support and data transfer. As all other major components of the system, it comes with a 3-year warranty. The Vector VR500 is a unique and world's only full dual GNSS positioning and heading device featuring one of the most modern RTK engine solutions. It embeds 2 antennas with a 50 centimeter baseline and an unrivaled heading accuracy of 0.2 degrees for this short baseline. To enable the simplest installation, a 400 megahertz radio modem and the UHF antenna are both built in the housing. So it offers seamless connectivity with Ethernet, Wi-Fi, Bluetooth, CAN, serial, and a sophisticated web user interface. The unit is tested against the industry's most stringent standards. So every single axis is tested against 50G for 30 hours, which is about 4 times higher than any other product available in the market. So the all-in-one character makes it unique and enables an excavator installation on small compact machines with 4 cables in total only. The large excavator solution comes with an Iron 1 PC, a VR1000 heading receiver antenna, and gyro-stabilized angle sensors. So the Vector VR1000 is one of the world's leading dual antenna GNSS position and heading receivers. It's using 2 A46 antennas. It features a heading accuracy of 0.1 degree at a 2-meter baseline on the back of your excavator. To enable the simple installation, a 400 megahertz radio modem is built in the housing. It offers seamless connectivity with Ethernet, Wi-Fi, Bluetooth, CAN, serial, and a sophisticated web UI. The VR1000 was developed against the highest automotive standards, as we did that together with a big OEM as an OEM fit. Plus, we had to comply to additional requirements. Each single axis of this unit is tested 32 hours for random vibration, followed by an aging section with temperatures raising and lowering between plus and minus 40 degrees Celsius. This and again followed by a 32-hour random vibration test. You can basically install this unit anywhere in the machine engine compartment, steel on steel, with no need of vibration supportive material. Additionally, we use gyro-stabilized sensor technology, so you have no lag time in response, meaning highest accuracy and clear visibility for the operator, even on long-reach machines. Even if broken due to a working environment, we keep cost for wear and tear as low as they are off-the-shelf industry components. Cost savings effective immediately. As we have seen before, this system technology is based on few components and 4 cables only. So you can already start saving cost before even using it. The installation time required by your distributor only takes half a day and the acquired equipment is easily interchanged between machine fleets. Here one example of why using grademetrix on your excavator. Imagine a better is overcut by 0.5 meter over 500 meter length. The overcut would total in 2,400 cubic meters. Additional excavator time could be as much as 25 hours, plus 166 truckloads would be needed at 15 cubic meters per truck. So the total cost would be more than the cost of the guidance system to prevent it. We used to hear from customer testimonials or advertising that the productivity technology for 2 machines are providing customers with 20 to 40% plus productivity gains. Fuel consumption difference between the 2 methods, as an example, represent about 30% savings. Time is another part of your saving equation, as you will improve the time to finish a job at least by the same percentage. This is represented by less passes required to get on grade, and we shouldn't forget that the closer the final grade you are on earth-moving operations, the faster the time for grading will be. Grademetrix will save you between 30 to 50% in material cost, staff cost, operation cost, and improves your production time by the same factor, ensuring benefits for smaller contractors and customers who just start to look into this technology. If you're doing mass earth moving and loading off-road trucks, an excavator is a good application, and maybe on the same job a dozer in the fill area. So you use the GNSS system to match slope on existing ground feature, extend a road, driveway or ditch along existing ground features, create new ramps and basic roads on board in the field, or simply create your in-field design on the display and you go. So case study 1, which was given to us by a company called Red Rock in Australia, that's exactly what the image is about. We talk about how much there is to gain from utilizing high-precision GPS systems on machines in mining. In this case, we were fortunate to receive some great feedback on 2 hemisphere high-precision digger systems fitted to some large mining excavators. The shading in the wall that you can see at the bottom represents dig compliance. Green is good. So previously a site may revisit a section of better 2 to 3 times to get it right, and not always successful, leaving valuable product behind. In only 1 week and a single pass, they got it on the money. Outstanding effort from the operators, great effort, and good to receive such great feedback from our valued client. So on the top of this screen, you can see the actual digital terrain model of that mine, and on the bottom, they made some checkings afterwards on how good the excavation was done. And as you can see, and as mentioned in the text, it's right first time, no more expensive additional excavating is required. The second one shows a case study which is more for standard construction site. So this is about rainwater retention basins, and in the past, so it seems that the job size played a very important role in the acceptance of guidance technologies. But what we want to achieve with the lower investment and price that we have is that customers basically can use it on a daily basis. So in this particular case, the surveyor hasn't even staked out the bassin, just only a couple of control points where the excavator driver could check the accuracy of his system, and the rest was simply designed by him and the 3D machine control system. And the last one, I mentioned that in the text before, shows how expensive an over or undercut can be. Again, as I said, just over cutting that by 5 square meters on a length of 500 meters will result in extra cost of $25,000, which is almost the price of the entire system. And now I will hand over to my colleague Ronald. He will share his screen and will run you through the presentation of the software.
Right, thank you, Jürgen. So I believe this should be visible already. So today I'm going to give a brief overview of what the grademetrix system for excavator can do. I will start with the operation and what the operator can do with the grademetrix for excavator, and I will cover some basic points. What you are seeing there is a project I already loaded. This project, which is called Maricopa, was made by our colleagues in the US, specifically dedicated for demonstration purposes. So once the system has loaded the surface, line work, and localization, and the GNSS receiver has a fixed position, you're ready to start work. Currently, we support many ways on how the grademetrix can display cut and fill information, critical for grading operations. These different views can be available in the upper right corner here. Among these views, we have plan section cut and fill, big cut and fill, plan section and profile, plan and section, profile and section, plan only, section only, dual excavator. So I'm gonna came back to plan section and profile, which in my opinion is the most common, the most useful one. This view, this menu will allow the operator to select from all these lists of predefined views. So the section view shows the bucket as the operator is seated on the cab and seeing the bucket out of the front window. If the operator wants to see additional information, just need to click over the eye, the information icon, and it will display additional information. This will display information related to the bucket and machine position. As you can see here, this north and east in elevation actually apply to the focus point or the control point of the bucket. In this case, the control point is indicated by this small triangle over here. If you want to change the control point to the other side, you just need to press and hold over the bucket, And then you can change this to the left side or maybe to the center. I would change it to the left as an example. Okay, now the information here should have changed accordingly to the change of the focus point. All right, the information showed here can also be set to the user preferences. To change the information available in the information icon, you just need to open the menu, and then go to the gear. And here in the info summary is all the information available. You can tick or untick, and just to show the information you are interested on. Okay, there is another interesting thing here. As you can see, there are some of the options in the main menu that are grayed out. So information related to open new jobs, to modify jobs, delete, and information related to or setup related to equipment setup, calibration, or articators are grayed out and accessible for users just to protect information. If you want to have access to all the options, you just need to come here and change to administrator mode. Of course, the access to administrator mode can be protected by a password. Okay, I'm going to get back to user. The grademetrix always starts in user mode when you start the system. Additional information can be found here in grade and monitor view. Information available here is usually used for example verification or diagnostic purposes. Among them, you have the VR1000 or the receiver information. In this case, it's a VR1000, but it could be a VR5000. So we have raw position information from the primary antenna of the system. We can also have, just for example, information about the solution we are using. If we have RTK fixed, how many satellites we are using, how many satellites are visible, the RTK status, the messages being used, and the distance to the base station. Then we have the sky plot, satellite information, relevant sensor information, and vehicle information. Here again, we have the local position of the control point, of the focus point of the bucket, and the surface exactly below it. We also have access to the 2D point check. So these distances are the distances calculated by the system from the boomstick, for example, to the bucket pin or to the teeth. This could be perfectly, this is, I would say, designated or designed to check if your calibration in 2D is properly done. Another thing available here is the 3D checkpoints. Here you have, again, the position of the right, left, and center teeth of the bucket. If you use a rover and measure the points, if the rover is connected to the same correction source as the machine, you can compare this measurement and ensure that your 3D calibration is properly, again, is correctly done. All right. So let's move on. So when a surface is created for a job, usually is showing the finish grade or the elevation of the last layer that job requires. The operator will have to adjust the offset, or just to adjust or maybe offset the thickness of that layer to get the proper cut fill indication to a subgrade. So grademetrix can change the target elevation. This can be done using different methods. As you can see here, so my bucket is touching the surface, and I have, it's almost is on grade. I can move, I can change my offset to a lower elevation, to a new target elevation, just pressing these arrows here. I can go down, I can go up. So in this case, I'm lowering my target elevation by 20 centimeters, and this dotted line is showing what is my new target elevation. Okay, I can also enter a specific amount of target, holding and pressing over the light bar, and this menu will pop up. So here I can enter a specific amount of offset. I will put here maybe, I will enter something like minus 0.6 meters. I can save this new value also in a preset. So I need to press and hold. I can also change here how big I want the steps to be every time I press the arrows in the side. I will change it to 0.2 just for purposes, for demonstration purposes. Now, if I can press 0.6, this amount of offset was applied. And you can see again that the red dotted line is displaying what is my new target elevation. Okay, now on top of that, every time I press up or down the arrows, the amount of offset that I'm applying is Now it's 20 centimeter, not anymore 10. Okay, so I believe we discovered how we can adjust the offset and how to move the surface to a new target elevation to make a space for new layers. So now that we know how to use, let me first change this to, this is another thing that I almost forgot. So we can save up to 9 different presets just for the speed of the operation. I'm gonna keep my offset now in 0. So now that we know how to use the grademetrix for a previously loaded job, we will learn how to create the job. So to create a new job, so we need to come here. As you can see, the new job option is grayed out, so I need to change to administrator mode, and then I can start a new one. The first thing the system is going to ask is to give a name to the job. I'm going to leave it as a new job. We can also add a description to the new job, and we can also add notes. Okay, then I will press next. So the first file that the system will ask for is the localization file. The localization file could be a full localization file in a log format, could be known points, and then we can shoot this point using a rover and do the localization on board. And we can also use localization files from Trimble or Topcon. In this case, I'm going to use the same project that you saw before, this Maricopa. So I'm going to click over here. I'm going to search for my Maricopa project. This could be saved in this case, in this design emulator. All this information is in my computer, but of course, if it was on a real job site, they're going to be at the USB, and the new driver is going to be listed in this space. So I'm going to open my Maricopa folder, and here I have my localization file, and I'm going to open this one. So here in Europe, it's very common to use geoids. So in this case, I don't have a geoid because this project was made in the US, and they are much more used to your localization file and not much of geoids. But here in Europe, the use of geoid is very common. I don't know in your regions, but if you have a geoid or if your geoid need to be used, this is where you select the geoid and load it to be used. Another important thing to load is the line work. The line work are the lines that you see on the working screen before. I'm going to also load a line work for this specific project. Okay, then if you have guidelines or surveys, topos as well, you can load it. In this case, I'm going to keep it simple as it is. And I'm going to press next. So the next thing is the surface. This is the last file that the system is going to ask for. I'm going to add a surface. And I'm going to open it. In the case, it's a DXF. So the surface contains the project finished. Grade attribute was elevated to the right elevation, which is going to create a 3D model that the grademetrix can read. Grademetrix support DXF, DWG, LandXML, and DTM, among others. Now, when I have this selected, I'm going to press next. So then is the units of record. In this case, it could be in feet, it could be in meters. I'm going to keep it in feet, given that this project was made in the US and this was made in this specific unit. This is a place where you can select your coordinate systems. If you need to use a specific predefined or a specific projection, you have a list of it, which is already loaded on the grademetrix. If your specific projection for any reason is not listed here, you can always come to custom projection and load your own. Okay? Then you press next, and I'm going to have a list of the control points or the localization points on this specific project that I was selected and loaded. So I'm not going to press finish now because I have already Maricopa loaded, and it's just going to consume time while it loaded. So I'm going to cancel this one. But this is a project that at the end, as you can see here, the name is the same. I can make zoom out, zoom in, and if I press cursor, it will focus on me. Okay, so another thing on top of that, there will be cases where the modifications need to be done to the specific job or entire new project needs to be done on site. We have included tools for that purpose. We call it field design. A field design does not require a localization file, line work, or DTM. It just needs RTK fix. For that, I'm going to start a new job, and I will keep it clean until the end. So I'm going to clean and not load anything. I'm going to start from scratch. So this is what we call it 2.5D. So in this case, you don't need to go to field design. And here we have 4 different options. We have flat path, sloped path, ramp, point surface, and an option to clear the last design that I made. So to create a flat path, I'm going to start with this most simple one. You just need to give the flat path to a name. I will call it flat 1. Okay. Then you need to go and place the bucket over the reference you're going to use to create that flat path. And you need to indicate what side of the bucket you want to use, left, right, or center. I'm going to leave it in left for this. And you need to place the bucket on the right position and press record. You can also edit the height or the elevation if you want. I'm going to change it to 100 meters. And press finish. As you can see now I have a new surface created by this specific design that I just made. If I, again, adjust my offset, the offset is going to be applied to the same surface. Okay, let's move on to the next one. The first thing that I need to do is to clear the design that I've made. So grademetrix is going to select the last one available, the last one designed, and ask me if I want to remove that one. I would say, yes, I want to remove the flat path. Now I'm going to create something a bit different, which is a sloped path. In this case, again, I need to give a name. I'll call it the sloped 1. And press next. Now I have to position the vehicle and the bucket again on the first reference I want to use to create the sloped path. And press record. I can manually enter this north and east elevation in case I want it. I want to change this to 100, just for demo purposes again, and press next. Now I need to position the vehicle at the second point and measure that position again. I move the machine, place the bucket over the second reference, and press record. I can manually change the bearing or adjust the bearing and the distance and the slope of that. I'm going to change the bearing to 100 degrees. The distance is going to be 80 meters long. And the slope, I'm going to fix it in 10 degrees. Okay, and press next. Now, I have the options to create an infinite slope path on each side of it, or I can say I can give that sloped path some specific width. In this case, I'm going to give a width at the center of 20 meters and across the slope of 5%. And finish. And this is the result. I have now my sloped path created. Okay, next I'm going to clean this design. And I'm going to create a ramp. A ramp allows to create something a little more complex design, including main slope, length of the ramp, and the ramp profile creation. As an example, I will create something similar to a piece of road. First, I need to give a name again. I will call it ramp 1. Okay, I have 2 options here. I can create a ramp of coordinates, so measuring the points using the machine, or I can follow a guideline. Imagine on the first, or one of the, a minute ago when Maricopa was visible display, all these lines that you saw there, you can use any of those lines or some of these lines to create a ramp along it. So the guideline gonna function or gonna work as the axis of that ramp. And the ramp gonna take the elevation of the line to use as an elevation of the ramp itself. In this case, I'm gonna go from coordinates. Okay, again, I need to position the vehicle over the first reference that I wanted to use. Select what point of the bucket I want to use to measure that. I will give it in left and press record. And next, now I have to fix the ramp direction and forward slope. Again, I move to the second position and repeat the process, hitting record again. It's telling me that my pointer is too close because given that this is an emulator, I cannot move the machine while emulating. in this space, so I'm going to enter some values manually. I'm going to leave the bearing as it is at the moment. I'm going to change the distance to 100 meters, and the main slope going to be 5 degrees. Now it's time to create the profile of that ramp. So the profile is being built, just adding pieces of that profile to each side of the center line, which is indicated here. I can add a piece to the left, to the right, or both sides at the same time. In this case, to save time, I will go to both. The line width is going to be 5 meters to each side, and the cross slope going to be minus 5%. And I will add these values to my ramp. Now, I want to make like a curve on each side of this. So I'm going to try something a little bit different. So the line width in this case is going to be 0, because I don't want any lateral displacement. So I just want to go up a certain amount. So I'm going to change this to, I have different options. I have run and raise, I have rise and run, and I have delta elevation. I'm going to change these to delta elevation. I want to go up by 0.3 meters. 0.3 meters. And I'm going to add this. And here is my curve. Now I want to add the sidewalks. The line we're going to be 2, and I'm going to change this just for them purposes to run and rise. In this case, I'm going to run 2 and rise 0.1. And I will add this. And here we are. If I press next, I have a plane view and a cross-section view of how this is going to look. If I press finish, now I have the ramp that I have created. Here I have my section view, my plane view, and also the system is giving me some guide to the center line, as you can see here. Also provides some kind of visual aid to allow me to follow the axis of that. Okay, the next and final, first I need to clean the design. I'm going to remove the ramp. And the last and final option for field design is to use or to create a surface out of points. In this case, I think I have some points already saved on this folder, so I'm going to just give a name, and I will call it from topo. Okay, and I will press next. Now, I'm going to search for my topo files. I have some points already saved here. This is the file, the point I have created. Oh, let me check something first. Sorry for this. Yeah, it's fine. I'm going to press next, and this is how I look. These are just some random points that I recorded in a previous exercise. And I will press finish. If I turn the machine, usually it takes just a moment to load this. And here we are. It's not visible here because there is no line work in this design. So to make this visible, I just need to go to the main menu, click over the gear again, go into surfaces and show this as design. And here we are. This is the design. As I say, don't pay too much attention to the design of it. It's just some random points that I have saved. Okay? And here we are. Again, if I apply the offset is going to be applied to the new surface. Okay, I'm going to clean this. Oops. So here we are. I'm going to clear the design. Just a moment, please, until this gets back to work. Now I'm going to open again. Oh, there is another option, which is called the Grade 2D. This will work exactly as any other 2D systems on the market based on. We can use laser as a reference as well, and we have several options here as well. So the 2D offered me 5 different ways to work. We can create a flat pad, single sloped pad, dual sloped pad, a trend and a profile. Given that this is very similar to what we have seen in the field design, I'm not going to spend time on this, just to show you how it works. You don't need to keep going until the end. And I have something that I previously created before, and this is a trend that I have created before. Okay? Just some other options to work in a full 2D, and in this case, you can also use a laser as your reference. And there is another two interesting thing that I want to show, but first I need to reload my Maricopa job again. I want to show two other small features that are quite handy. Here we are. This is a little bit crowded, so I'm going to get back to my former view, and I change this to as build just to see, institute all the grid or the team. I'm going to see my landmark again. So I'm going to move my machine back. As you can see, there is one point here. One of the control points is located close to the machine. So I have two interesting features as well, which is navigate to and check position. If I want to go and navigate to a single point, I want to go, in this case, in Maricopa, I don't have topo points, but I have control points. I'm going to select this one, press OK, and the system will tell me in what direction I need to steer and where I need to go to place the bucket over the control point that I want. In this case, it's going to be approximately there. When I'm on the place, I can exit. Now I can check the position on that specific point. So in this case, I'm going to select the point that I know that I'm over it. I can select which side of the bucket I want to use to check, and I'm going to press check. The system will compare the position of the pad, the position of the bucket compared with the reference that I got, and it will tell me the offset, the measured offsets to the position, and the residuals as well. Okay. So last thing that I want to cover is some of the RTK options we have available in grademetrix. So the grademetrix offer the chance to work with RTK over Entrip or over radio. That you need to come to the main menu. I will show that again. Go to the main menu, move to the right, and we have RTK source configuration here. So we can use a UHF radio. Could be the internal one on the VR1000 or VR500 or external. If you select the internal radio, the system will give you the chance to set up your frequency channels and the bandwidth. Then you can select also the protocol you want to use. And is the effect going to be on and off? If you are willing to do, if you have to use external radio, the only thing that you need to set up on the grademetrix is the baud rate or the speed of the connection, because all the rest is going to be set up on the radio itself. And the last one is the Entrip. For the Entrip or RTK over Internet, so grademetrix can access to Entrip cards, the service, using an internal Entrip client and a GSM integrated modem. The display has a SIM slot for that. Just enter the right caster detail and you're ready to go. And as an option, multiple casters can be edited and saved. So the GSM modem also allows remote access to the display using TeamViewer or remote support, as this works in Trimble. Sorry, this works in Windows. And with that, so I have finished with this short presentation this short demo that I wanted to present. So as Jürgen already say, if you have any question, send it over, place it in the chat, and we will answer at the end of the call. So I will stop to present my demo now, and thanks for your time and your attention. Jürgen?
Thank you, Ronald.
Welcome.
So back to the presentation that we had. So just a quick summary. It's what we offer here is something called what we call performance, simplicity, and value. So our solution offers an unprecedented value in machine guidance. And I guess we can think about pairing the lowest available system price on the market with highest available precision and performance together with a market-leading 3-year warranty. So precision and reliability at an affordable price. There you can see, and the price of $30,000 here is even a little bit high. I mean, the VR 500 system for compact excavators using the VR 500 receiver, that starts actually at a list price of $27,900 MSRP. Of course, you need to calculate a little bit shipping and customs in different countries, but that's about the starting price that we have. If you want to talk about euros, that's probably at the moment like 26,000 euros. And then compared to a Trimble Topcon or Leica system, we are well under the price of the market right now. And what is important, it includes all GNSS signals and activations. So I want to just briefly touch what we call site metrics, which is an additional part of our machine control solutions. So site metrics basically is a software that is like a universal construction site supervisor system. So it includes our C631 RTK base and rover, so you can use it as a base system, or as a base and a rover, and it's a tool to help you manage all of your job site activities. So it was designed to be user-friendly because it's basically the same background and the same format as the grademetrix system on the machine. It's easy to understand, portable and extendable. So we designed that to specifically used by site supervisors, inspectors, and grade checkers. And it's an easy-to-use software for day-to-day surface and grade management tasks, and it works either on the pole, like on a standard survey rover, or in a vehicle if you want to track as-built points on the go. So you can move it seamlessly from man rover to monitor rover on a pickup. It's as a grademetrix system, quite simple to learn and to use, and it provides direct import of DWG, DXF, and machine control files, and there is no desktop software required. So job site supervisors can get daily, weekly, or anytime volumes, track real-time results of cut and fill, plus they can collect stake points. So using the system to localize sites, check grade, configure base stations, set up your own stakes if you don't want to wait for a surveyor, and calculate volumes of materials removed. So depending on the business dynamics that you have, your return on investment could be as short as a matter of months. So it fits straight into any existing site infrastructure with all the same formats and base station corrections. And you take control of your projects, improve your efficiency to get your jobs done a little bit faster. So you have control over your entire job and are not always dependent on your surveyor. So you can do it yourself and save time, fuel, and labor and cost with the ability to have a management system in the hands of your own site foreman. What is quite important here, and Ronald did not really fully touch it in his presentation, but the installation and calibration process, especially for the distributors that we have in our audience, is quite a unique way. So a trained engineer can install the system basically in between 4 to 6 hours, including the calibration. So what we have here in the site metric system is a way that for your 3D calibration of the position of the antennas, we are not measuring them as other players in the market are doing, or we don't need a robotic total station for measuring the machine for that. So what we do is we have designed 6 points around the machine, which we basically go with our rover and the site metric systems and stake out those points and then import that file via USB stick to the system, to the grademetrix system, and that will give you your full 3D calibration. So as the system itself, we also want to make installation and the calibration as easy as possible. Of course, what is also important with the C631, it also has, like our S631, the tilt function included. So you can use it for tilted, pointing out tilting points and anything else you need for a GPS rover. Very easily swappable between base and rover solution. So best case scenario, the job site supervisor will get a full kit with 2 units in place so that they can really use it for all kind of applications that they have. And now I want to go to show you at the end of the presentation a couple of the options that we also offer. And for that, I need to share my screen because it's 3 very small videos. So hopefully everybody can see that. So what we have on the run now is the rototilt option. So we are just about to test that and then release it to the market, which is not very common in all countries in the world, but in some countries it's becoming more and more popular. So we have the rototilt function. In order to cover, let's say, the whole seamless or to cover the whole stream of the job site, we also offer it as a solution for wheel loaders. So in many countries we see that the wheel loaders are used for finish grade and instead of a motor grader. So we have an application there. And last but not least, and sometimes maybe also applicable for agriculture, we have the skid steer solution ready in the next release. So that's it. We thank you very much for your time in joining today. And as we said before, if there are any questions, just feel free to put them in the chat, and we are here to answer.
And Jürgen, just to add, there is the handout tab on the side that you can click all those to download on your own computer as well.
Okay. Yes. Thank you, Lissy.
So Jürgen, we have a few questions from the audience. So some of them I can answer them, and some of them you have to answer. I believe a couple of them already answered. So one of the questions is about what type of files the grademetrix accept. So the answer for that is the grademetrix can support the following. Depending on the file that you load in and the part of the process you are, it will support a variety of formats. For example, for the surface model file, it could be DWG, DXF, 3D phase triangle, polylines, TIN, FLT, LandXML, and LandXML read. For the topo file, it would be topo. For the TIN file, it would be mesh, TIN, NTR, DXF, DWG, NFLT. The GeoID file, the GeoID file is going to be bin. Localization file is going to be local. Line work, it will be DWG and DXF. And again, for the calibration files, could be Topcon or Trimble. This is one of the questions. Another question is, well, this was already answered. What does the installation procedure look like? So you already answered that part. So another question is, if we can use a system without surface line work or localization, yes. The answer is yes. So I already explained that when I talk about the field design. Nothing of that is needed, just RTK, you can perform the full design on the display. Mm-hmm. Then another question is if there is any extra charges for software upgrades. You can answer this one, Jürgen.
No, there is. We basically don't charge for any software updates in the future. So everything which will give you enhancement of the system or extra features, those will be free of charge, like the GNSS activations. I can't really, or would like to say that again, that the GNSS receiver that we have on board is fully activated for all 4 constellations. So especially in those difficult environments like the open pit mining or next to trees, there is a difference if you have only GPS and GLONASS or all 4 constellations available. And again, of course, it's always dependent on what kind of correction data you're getting, but that is no charge at all.
Okay. And the last one that I have is about the warranty. How long the warranty will protect the system?
As mentioned in the display, it's we offer a 3-year warranty on all the major components of the system itself.
Okay.
And
that's all I have.
Yeah, last one. What I want to say again is just to come back to the kind of applications and features that we have. So we would like not to compete to the traditional 3D market. Of course, we can do all the features, but we want to emphasize people and users to use the system on a daily basis, building houses, building, as I said, retention bassins, building trenches, and utilize it. In most of the cases, you can even do that without being a surveyor. Just set up your base station, let it self-survey, and then you have RTK corrections. And as Ronald showed in his presentation, you can create the jobs on the fly without having the necessity of having a 3D file available. So that's good. Any other questions from the audience?
Nothing else.
Well, then I think we can call it a day. I want to thank everyone very much. As I said, you have my contact details. If there's a technical question, I will forward that to Ronald. Again, thanks a lot, and good time to everyone, and hope to see or speak to you soon.